Hey everybody, Mr. Piercy here, and we're going to be looking at how we measure and classify angles today in this video. Now, some of the information that you're going to see here is probably information that you know already, as far as how we classify angles as acute, right, obtuse, things like that. But some of this stuff will probably be new, so make sure you get all of the information down into your notes, and we'll go from here. Now, I would imagine anybody that has ever taken junior high math would be able to identify angles. Like if I just gave you a whole bunch of shapes and said, find the angles, people would be able to tell me what the angles were, but probably not be able to give me a good definition of what an angle was. So please make sure you understand that an angle is made up of two rays that have a common vertex, and the rays themselves would be the sides of the angle. The way that we measure angles typically in high school geometry is going to be in degrees, which is what most of you are typically used to thinking of. You know, you have a circle that has 360 degrees. The sum of three angles in a triangle have a sum of 180 degrees. Well, a radian is another way of measuring an angle, like yards and meters are different ways of measuring a line segment. Degrees and radians are just different ways of measuring an angle. We won't speak too much about radians in high school geometry, but we will talk about it some. Here on the right, if you haven't paid attention to what an array is, please make sure you make a note of what I'm giving you here as far as array. Array is named by saying we have an endpoint, then we're going to another point somewhere. The symbol that we see here for array, if you're having a hard time seeing it, looks like that. It is a single, it's a line with an arrow on one end. Now, one of the things I want you guys to understand is the arrow does not indicate a direction. It's simply saying it's talking about array. So here, when I'm talking about array AB, I'm talking about this right here because I'm starting at A and then I'm heading through B. Where I'm saying ray BA, here I'm looking at this ray because I'm starting at B and then I'm going through point A. They're not the same ray, even though they have the same points. So coming down here with how we classify the angles, acute, right, obtuse, and straight are probably ones that you're pretty familiar with. Congruent, that word congruent is going to be used a lot. It simply says we have angles that have the same measure in this case. And an angle bisector is going to be a ray that divides it into two congruent angles. And we've talked about angle bisector when we talked about our congruent, our constructions. The one here that's off to the side that you may not know, it's hard to read. This is called a reflex angle, and its measure is going to be greater than, its measure is going to be greater than 180, but less than 360 degrees. And we'll see reflex angles a little bit more when we talk about circles. So go ahead and take the time that you need to get the definitions copied down. But in the meantime, let's go ahead and talk about how we name angles. In the diagram that we see here, we have three very distinct angles. We have angle ABC or angle CBA. We have angle CBD or angle DBC. And we have the overall angle ABD or DBA. Now, if you notice, the order that we name the angle as far as the points that we use doesn't really matter too much, but the vertex point always needs to be the middle letter. It would not be appropriate to say that any of these angles are called angle B because three angles use the same vertex. So if you say angle B, I'm going to say which of those three angles are you talking about? Here we're looking at protractors. And we want to make sure, can we measure an angle okay with our protractor? So here, what you're seeing when we measure angles on our protractors, again, we're talking about the absolute value difference, just like what we did with our ruler postulate. So for instance, if I had another ray that came up this way, and I want, let's call this point Z. If I wanted to know what that angle here is going to be, I can take the values for each ray and subtract them and take the absolute value difference and find the measure of the angle that way. So here we want to know, well, can you actually measure the indicated angle, and then can you classify it by whether it's right, obtuse, etc. Okay? Okay, so sorry I had to pause the video for just a second, but here let's go ahead and measure these angles. So let's just take a look at the first one, WSR. So WSR is this angle right here. Looking at it, we should be able to classify that as acute because it definitely looks less than 180 degrees or less than 90 degrees. But again, we try not to say something is or is not because of the way it looks. So let's just measure it. We always start wherever 0 is. In this case, 0 is on the outside number line. Oops, that's not what I wanted to do. So I'm going to follow the outside number line up and around until I get to the other side of the angle. And when I see that, I see that I've stopped at about 65 degrees. So we always start at the outer number line or wherever 0 happens to be. Let me rephrase that. We don't start at the outer number line always, just wherever 0 is. In this case, we started at the outer number line because that's where 0 was. We measured it to be 65 degrees. So now let's take a look at it. The next one, TSW. So here's TSW. So again, I'm going to see, well, where is 0 at? In this case, 0 is on the inside number line. So I'm going to follow the inside number line around. And based on appearances, this one also seems to be obtuse. So I expect the angle measurement to be greater than 90 degrees. And in this case, I'm following the inside numbers around. And even though we stop at the same place where the first angle did, they're not the same measurement. In this case, it's going to be 115 degrees, because we're just following the numbers around, and you see we're right in between 110 and 120, so 115 degrees. The other two angles that we're going to take a look at here, angle RST, let me pick another color. Angle RST is just this right here, so that's a straight line, so that means it's a straight angle of 180 degrees. And the last one that we will kind of take a look at here is angle VST here. And looking, it doesn't matter which one that we follow along, we're still going to kind of follow along the inside number line here. And we see we stop that one at 90 degrees. So that is a right angle. So go ahead and pause the video at this point and answer the two questions that you see here. And when you're done, hit play, compare your answers with mine, and see how you did. Okay, so hopefully you've had a chance to answer the questions here and see what we come up with. So name all the angles. In this case, again, there's 3 specific angles. So here are all the possible names for the 3 angles that you would have seen. What type of angles do the x and y axis form on a coordinate plane? They form right angles because horizontal and vertical lines are perpendicular. Again, make sure you're kind of paying attention to how you write your sentences. Make sure you give your complete sentences whenever you have to give an explanation for something. Now here, the angle addition postulate, this is very much another thing that I can accept to be true without having somebody to explain why it's true. If I take one angle and combine it with another angle, we can see that together they create one big angle. So the sum of the big angle is whatever the 2 smaller angles happen to be added together. Now, again, going back to what we were talking about for angle addition, comparing it with segment addition, if you notice here with our angles, they're not giving us numbers for the angles. They're giving us algebraic expressions. And they're saying that the measurement of this angle, GFJ, which is the overall big angle, that has to be 155 degrees. Well, based off of what angle addition says, the measurement of the angle GFJ has to be equal to the measurement of angle GFH and HFJ combined. Taking that information into account, now we can substitute the values that we know. the overall angle is 155. The two angles are their representative or their respective expressions. Combine your like terms on the right side of the equal sign and we get 8x plus 3. Move the 3 over through subtraction and then divide by 8. And then we say that x is equal to 19. Now that I know that x is equal to 19, I can go back and substitute it into the respective angle expressions and show that angle GFH is 180 degrees and HFJ is 75. In problems like that, make sure that you're showing me how you're setting up your equation, what you're substituting, and show me all of your math that you use to arrive at the value for x, and then whatever you do to find the measurements of the independent angles. Okay, you have to show me what you're doing on those. So here we want to be able to identify congruent angles. Now if you notice here, this angle L has two little arcs on it and this angle M has two little arcs on it. The number of arcs in an angle indicate whether the angles are going to be congruent to each other or not. So coming down here, angle P has one arc, angle N has one arc. So those are going to be congruent to each other. Because angle M and angle N have different arcs, these are not going to be congruent to each other. So in this case, the angles that we know are congruent to each other, N is congruent to P, M is congruent to L, and therefore the angle measurements have to be the same. So if angle P is equal to 120 degrees, angle N also has to be 120 degrees. And now we're taking a look at a double angle measure. Okay, what they're letting us know here, if you notice in the diagram, this is a single arc, this is a single arc. That means the measurement of angle XWY and angle YWZ, those are going to be the same. So I can show that the two angles add together to be angle XWZ, or I can say that angle XWY is equal to angle X or YWZ, which is what we're saying here when we say that they're congruent. So that allows me to say that the measurements of the angles are the same, and say that, well, if one of them is 29, the other one has to also be 29, so the overall angle that we're looking for, XWZ, is 58 degrees. So here we are kind of at the end, and we'll go ahead and pause the video, answer these two questions, and when you're done, come back and compare your answer with mine. Okay, so I'm assuming that everybody's got a good answer here after pausing the video and seeing what we have. Identify all pairs of congruent angles in the diagram. Well, in this case, based off of the markings in the diagram, angle B and D are congruent, angle A and C are congruent to each other. So since D is 135, that means D also has to be 135 degrees. And here we're saying that KM bisects the angle, and angle LKM is 78 degrees. So based off of that information, I can show that the overall angle has to be 156 degrees because, ooh, I forgot my angle symbol here. Angle MKN is also going to be 78 degrees. So add those two together, and that's where we get our 156 from. That's it for how we measure and classify angles. If you have any questions about anything, by all means, let me know what they are, and I'll be happy to get back with you. But until next time, ladies and gentlemen, thank you for watching, and hope everybody's good. Take care.